Hi everyone, welcome to the course on blockchain and smart contract. Over the next few sessions, we will know the fundamentals of blockchain, explore its role in cryptocurrencies, and combined into enterprise blockchain applications. So these are the course objectives and roadmap of this course. The first course objective is understanding blockchain fundamentals. First, let's get familiar with the basics of blockchain. So blockchain is a decentralized and tamper-proof ledger that records transactions in a structured way. Each transaction is grouped into a block and these blocks are linked together in a chain. This structure ensures that past records cannot be altered without affecting the entire chain. This making blockchain highly secure and trustworthy. The second core objective, Bitcoin and cryptocurrencies. We will also discuss Bitcoin, the first successful cryptocurrency. We will cover how Bitcoin transactions work, the concepts of digital currencies, and how they are transforming financial system worldwide. The third core objective, consensus mechanism in Bitcoin. To maintain a security and validate these transactions, Bitcoin uses a consensus mechanism called proof of work and proof of stack. We will explore how the proof of works, why it is crucial for securing the network, and how other consensus mechanisms differ from it. So the fourth core objective, enterprise blockchain platforms, Hyperledger Fabric, and Ethereum platform. Beyond cryptocurrencies, blockchain is widely used in industries like finance, healthcare, and supply chain management. Two major platforms leading these spaces are Hyperfabric and Ethereum. Hyperfabric is a permissioned blockchain designed for enterprises applications, while Ethereum is known for its smart contracts and decentralized applications. We will take a closer look at both. The fifth core objective, smart contract and their mechanisms. One of the blockchain's most powerful feature is smart contract, self-executing contracts where the terms are directly written into the code. We will discuss how smart contract work on platforms like Ethereum and Hyperfabric, Hyperledger Fabric, the different consensus models they use, and how the security is ensured in smart contract execution. So this is the topics we are going to discuss in unit number 1, Introduction to Blockchain. In this unit, we will explore the fundamentals of blockchain technology and its key components. We will begin by understanding public ledgers and how blockchain function as a decentralized tamper-proof ledger. This means that no single authority controls it, and once a data is recorded, it cannot be altered. Next, we will break down the structure of the block and how transactions are linked together to form a chain. This leads us to an important concept, the longest chain rule. This longest chain rule ensures that all the participants in a network agree on a single version of the truth. We will also introduce the permissioned blockchain model, which is used for restricted access applications where only authorized user can participate. This is especially useful in industries like banking and healthcare. Another critical part of the blockchain is cryptographic hash functions. We will discuss how they secure the data and maintain integrity. We will learn about hash pointers which link blocks together securely, and we will also discuss about Merkle trees which help verify the transaction efficiently. By end of this unit, we will have a solid understanding of how blockchains work from its core principle to its real world applications. Okay, now we see what is blockchain. Blockchain is a revolutionary technology that supports cryptocurrencies like a Bitcoin, but its application extend far beyond digital currencies. Here is a more detailed explanation of what is blockchain is and how it works. So blockchain is a peer-to-peer distributed ledger that is cryptographically secure, append only, immutable, and updatable only via consensus or agreement among the peers. So what is meant by peer-to-peer distributed ledger? So blockchain operates on a peer-to-peer network. So the meaning that all the participants or nodes in the network communicate directly with each other without the need for a central authority or intermediate. The ledger which records all the transaction is distributed across all the nodes in a network. Each node has a copy of the entire ledger that ensuring no single entity has control over the entire system. This decentralization enhances security and transparency. Cryptographically secure. Blockchain uses a cryptographic technique to secure data. Each transaction is encrypted and linked to the previous transaction, that forming a chain of block. Hence, the name of blockchain comes. Normally, it uses a hash functions for this cryptographic technique. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. The hash function ensures that even a small change in the transaction data will produce a completely different hash, making tampering evident for this process. Digital signature. The transactions are signed using a digital signatures which verify the authenticity and integrity of the transaction. This ensures that only a rightful owner of the asset can initiate a transaction. Append only and immutable. New transaction can only be added to the blockchain in a sequential manner. Once a block is added to the chain, it cannot be altered or deleted. What is meant by immutability? So the immutability of the blockchain means that once data is recorded, it is extremely difficult to change. If you want to alter a single block, an attacker would need to change every subsequent block in the chain, which should require an enormous amount of computational power and coordination across the network. This makes the blockchain highly resistant to tampering and fraud. Consensus mechanism. So, for the transaction to be added to the blockchain, it must be validated by the network through a consensus mechanism. This ensures that all the nodes agree on the state of ledger. So, proof of work works. The nodes compete to solve complex mathematical puzzles. The first one to solve the puzzle get to add the new block to the chain and is rewarded. This process is resource intensive and secures the network by making it costly to attack. Proof of stack is another function performed in the consensus mechanism. The validators are chosen to create a new block based on the number of coins they hold and are willing to stack as a collateral. This method is less resource intensive than power of proof of work. The other mechanisms, there are the other consensus mechanisms like delegated proof of stake, practical fault tolerance, and more, each with its own advantages and disadvantages. Decentralization. So, what is the meaning of a decentralization? Means no central authority involved in this transaction. Unlike a traditional system where a central authority controls the ledger, the blockchain is decentralized. This decentralization reduces the risk of single point of failure and increases trust among participants. It is a transparency. Since all the transactions are recorded on a public ledger, anyone can verify the transaction. This transparency helps in building trust in the transaction and accountability. Next, we see the use cases beyond cryptocurrency. So normally the blockchain used in smart contract. So the blockchain can execute self-executing contracts with the terms of the agreement directly written into the code. Ethereum is a popular platform for smart contract. Supply chain management. The blockchain can provide transparency and traceability in supply chains. This process ensuring the authenticity of the product and reducing fraud. And it also used in healthcare industries. So blockchain can securely store patients' record and it ensures that only authorized personnel can access them. In voting system, blockchain can be used to create a secure and transparent voting systems. This reducing the risk of fraud and ensuring the integrity of elections. Identity verification. The blockchain can provide a secure and immutable way to verify identities and reducing the risk of identity theft. The security and trust in blockchain. The tamper-proof. The combination of cryptographic techniques, decentralization, and consensus mechanisms make blockchain is highly secure and tamper-proof. And it also involved in a trustless environment. So blockchain allows parties to transact directly without needing to trust each other or a central authority. This system itself ensures the integrity and security of transactions. Even it comes with different features, there may be some challenges and limitation in blockchain also. The first challenge is scalability. As the number of transactions increases, the size of the blockchain grows, which can lead to scalability issues. And another one limitation is energy consumption. Some consensus mechanisms like a proof of work that require a significant amount of computational power and energy that leading to environmental concern. Another one limitation is regulation mechanisms. The regulatory environment for blockchain and cryptocurrency is still developing, which can create uncertainty for business and users. So finally, we can conclude that the blockchain is a transformative technology that offers a secure, transparent, and decentralized way to record and verify all the transactions. Its potential applications are very vast, ranging from finance and supply chain management to healthcare and voting system. However, like any technology, it comes with its own set of challenges that need to be addressed for widespread implementation of this blockchain.